Hello, everyone. This is Mr. Taylor with Young Engineers Today. This is a recap of our webinar on Monday, December 14th, 2015. All right. What we're going to be using here is Scratch GPIO on the Raspberry Pi. You're going to need all your Raspberry Pi equipment that's been given to you, plus a keyboard, mouse, and monitor attachment, and all the proper cables. Make sure you have the correct SD card, as well as your joystick and buttons. Okay. Now, this is an old school arcade game called Asteroids. Our goal is to become confident understanding this code so we can change it to become easier or more complex, have physical input so we do physical computing and customize it to our needs. Now, this Scratch Pi game is called Asteroids. You'll need your joystick and a button. You haven't yet opened it up in Scratch and play it for just a few minutes. This will help you get familiarized with the mechanics of the game and that the code will make intuitive sense. You'll find this one to be far easier in Space Invaders. We haven't done Space Invaders in 5th and 6th grade. That's for middle school students. Now, let's look at the code and let's break this down. First, the ship's code. We're keeping all of our code in a forever loop. So anytime your flag is clicked, the game reinitializes. Specifically, initializes default costume, initial position to 0, 0 in the XY coordinates, initial speed to 0, lives to 3. So you're playing with 3 lives before the game would reset or come to an end. Score to 0, and we're using Boolean to 0 or false. You'll see with our Boolean logic, 0 being false and 1 being true. Then the code gives the ship some motion. Here's where we will be adding the joystick later. This repeats until loop makes sure our ship can move until we run out of lives. When the ship has not been hit, left arrow turns your ship 15 degrees counterclockwise, and right allows to turn your ship 15 degrees clockwise. The up arrow will let the ship move. The if statement that checks the forward speed will increase the speed's variable, and after will decrease it. Your ship will start to slow down as the game goes on. Next bit, we'll let our ship fire. This is where we'll be adding our button into the game later. In this if statement, the game checks that 1, the ship isn't already firing, 2, the ship hasn't been hit, and 3, the space bar is pressed. For it to use this whole if statement here, everything has to be true so that you can fire. If all 3 of these conditions are true, the game will change the firing Boolean variable to 1, which I stated earlier is true, identify the direction to shoot our laser, and broadcast our laser that it needs to be shot. Unlike other Space Invaders, which we're not going into, it needs to be defined by the amount of steps it takes when an input is received from the player. The game then stores the ship's new coordinates in the variables ship and X and ship Y, because it's all based off the location of the ship. Then it waits a short time until it jumps back into the loop and just to check if there are still lives. If there are no lives, we get a game over message. We also get a message telling us to hit enter to restart. This will give you a restart and broadcast a starting of a new game. Now, developers do different things and different methods to accomplish the same thing or whatever they desire. Okay, next, the laser sprite. This code will be initiated by a broadcast from the ship. Our ship has also set a variable called shoot direction. Here we use the variable to direct our shot. The code also sets the laser's initial position to the same as the ship's. You probably know this because it's based off the ship's location. We also show the laser since we probably like to see it and play a laser sound. Our laser is going to move until it hits the edge in which case it disappears. We then set our firing boolean back to 0 so that our player can shoot again. We also set our laser to be initially hidden when the green flag is clicked, because we don't want to see it, only when we're using it. Now, click on the asteroid. We're going to go through the asteroid sprites code, and this is for any of the asteroid sprites. Nothing we haven't seen before. We make sure our initial costume is the one we want, and then show our asteroid. The asteroid's movement is going to be randomized. The variable called side will be set to a random number, and the asteroid initial position will be set through the following if statements. If the code receives a 1, the asteroid will start at the top of the screen. We set it to the top of the screen with a variable called start y. The initial x position also set randomly. And the x is between -250 and 250. What you have to realize is that in the center of the screen is xy of 0, 0. And then you have 4 areas of the screen. Broken up, the top right area is positive x and positive y. The bottom left area is negative y and negative x. Then our top, as you can continue this pattern, we are getting a positive, you have another positive, negative, then the inverse in the bottom right of a negative positive. So now if the code receives a 2, the asteroid would start at the bottom of the screen. We set to the bottom. You can see this continuing happening here. You have a 3 and the same for a 4. Okay, it's all this randomized areas based off of which x and y being negative or positive. Now the asteroid will then move in an initial position and then get set to a point, move in random direction. The speed is also set to a randomized step. The thing that makes this great is that every time you play, it's always going to be different. The asteroid will then continue to move at the amount of steps it was randomly given. If it's on an edge, it will bounce. The asteroid will do this until it gets hit with a laser or touches your ship. We then set what happens when the laser and asteroid collide. First, we increase the score, and then we quickly change the asteroid's next 7 costumes. Now, I want you to notice is that the point 1 allows it to be delayed just enough so when it switches costumes, it looks like it's breaking apart, as you can see in this slide. This gives the illusion the asteroid is actively exploding, a bit different than some other games you might have done on Scratch. He changed the size of one costume rapidly to give the appearance of an explosion, as you can see from Sprite 1 through 8. If the asteroid did not get hit with a laser and it's not longer hitting the side, the only other option is that it hit your ship. So it broadcasts back to the ship, and then within your ship's code, it receives a broadcast collided with the asteroid. First checks to see if there's any remaining lives. If so, it changes the hit boolean to 1, aka true, and decreases lives. If not, it would bring it to an end. But it plays a sad music and changes a costume for your sprite as well. Now the ship collision, next piece of code, makes the ship pause before returning to its initial position. It makes sure the costume is correct. It resets the hit boolean to 0 or false or not hit and sets it forward speed to 0. Now, so let's add some joystick controls to this game and make it feel like a real arcade. Do you remember how to hook up your joystick? If not, please hook up your joystick. Like this is your joystick, and from left to right, you have your wire connectors for 1 through 5 and their controls. Make sure your Raspberry Pi is facing north with the SD card, and your USB port should be facing south in its orientation. And then connect these hookups. I recommend pausing the video right now and making sure you connect these correctly. It's important that you follow this correctly, because if not, your joystick will not work. And then please add a button. I recommend pausing right now and hooking this up correctly. All right, next we need to set up our GPIO pins as inputs, and let's do a quick test run to see if it's working. Open a new file and code this. Okay. Now, also make sure you go up to edit and turn your GPIO server on. Tell me what's happening. and we stopped here. All right. Thank you. And okay.